Today, I'd like to share with you very short presentations about using the e-learnings and innovative tools to increase learning motivation in junior science curriculum. My name is Danny Wong, and I have been working in Hong Kong local school for around 6 years. My main teaching focus will be in junior science, especially Form 1 and Form 2 topics. I will also take the DSE biology teaching duties with my panel heads. Currently, I'm the head of junior science, so I need to plan the school-based curriculums. I have very strong cooperation with EduHK. I complete my PhD here, and now I'm the MS students with majoring science educations with a very generous UGC scholarships. For my school, we would like to adapt the school-based curriculum in junior science. For example, we want to foster inquiry-based learning, promote collaborative learning like group discussions, they're working on practicals, and we emphasize on science projects all the time. For summative assessment, our school is quite good schools with well-renowned public exams results. However, in Form 1 and Form 2 only, we don't want to just talk about the public examinations. We want to implement more formative assessment. And most importantly, some cross-disciplinary connections. If you are interested in STEAM educations, we also want to talk about transdisciplinary, interdisciplinary cooperation between each of the subjects. We don't want to treat the subjects independently one by one. We want to implement more innovative tools and prepare for the new junior science curriculum starting on the year 2027. Currently, the Hong Kong SR government try to use a new science curriculum in primary school, and in the coming next couple of years, the Hong Kong local school will adapt a brand new science curriculum. We want to use more e-learning activities and also some innovative teaching tools to increase the boys' learning motivation. First of all, I'm working now in a boys' school. For Form 1 to Form 2, there are 4 classes, approximately more than 130 boys. So you know that the teenager boys are very active. To be very honest, they are naughties. They don't want to sit here to listen to you for an hour, acquire the knowledge how to operate the circuit, what is photosynthesis, what is respirations, why we need to learn the mystery of matters, practical theories. They want some experiment. And they also want to have more e-learning tools to help them to construct the knowledge. Rather than sitting here memorizing the textbook and they pass the exams, they go to university in 6 years later. So we want to increase their learning motivation. After the pandemic, we observed that some students have difficulties in understanding the abstract scientific concept. They may not be very self-confident in learning and also be a very moderate teenagers. And we want to have a stronger resilience thinking in this kind of the junior boys, develop their science process skills, and also we want to have the better scientific literacy to be developed throughout the school-based curriculum. Similar to GIFT educations, we established 3 levels supporting our junior boys. The first level is more or less just in-class teachings. Okay, we have that every cycle around 3 double lessons. In total, there are 3 hours of teaching the junior science, including some project introductions, presentations, also some practicals. Second levels, we have a lot of core subjects projects. For example, the first year I came to this school, we cooperate with the PE department. We cooperate with the computer literacy, design and technology department to work on various STEAM projects. And the third level usually belongs to those very gifted students. I would like to use the term elitisms because we will select some student joins the local and international science fair, science competitions, things like that. Throughout the lesson design, we don't want to talk for 1 hour. Especially for me, I think that for inductive teachings and deductive teachings, I would like to allocate the time like I teach for maybe 15 to 25 minutes. That's it. That's the deductive teachings. Then I will have inductive teaching parts. Students can have some student-centered learning. We want to engage them into learning, not just trying some practical from the school textbook. Those are very traditional, conventional practicals, but we also encourage the student to have more e-learnings that we will see throughout this PowerPoint. The available e-learning activities not limited to using VR or AR. For AR, it's very important, especially for biology teachers teaching the anatomies, the various organs functions, also, yeah, you name it, many different kinds of things. VR, for example, visiting different habitats. That will be very easy. We don't need to wait for field trips. For my school, field trips is usually for the Form 5 boys. We have the EDV online learning platform available. It's free of charge, and all Form 1 to Form 3 students will join it. Okay, the online platforms. We have the PhD simulation employed. Actually, it's a foreign website that you can use it all the time. We have developed AI in the various tools. Today, we may not have enough time to talk about the using AI in traditional science lessons, but I think that more and more science teachers are now using AI to assist their teachings. And we install various apps on the iPad so the students and teachers can learn it together. Here are just like still some pictures of the possible student-centered learning activity using VR, using some simulation. For example, if you teach the Form 1 matter, it's difficult for students to think about the different solid, liquid, and gaseous stages, and then the practical arrangement. They just read the textbook, and then they just revise it for the examinations. That's it. However, using the simulation, we create different opportunity for them to learn. They need to test the different conditions and then their effect. For example, increasing temperatures, what will be the effect of the air pressure? Decreasing the total volume, what will be the effect of the final pressure of the whole system? Okay, so we can ask them various questions to develop the inquiry mindset. And then we have adapt some so-called sensor, pH sensor, force sensor. Today I just have my Form 2 lessons, and me and with the boys, we have used the motion sensor and force sensors to work on force and motion. Some of the physics teachers will think that these sensors are available only to senior form students. However, for my school, Form 1 and 2 students are invited to use this kind of sensor, same as the senior boys. It's not just designed for DSE physics subjects, but junior boys can use it. On the pictures, you can see that there's a calorimeter. Sometimes we'll use it for Form 1 for learning the matter about the concentration and the amount of matters at their proportional relationships. And then we have the various teaching tools like the Google Lenses for AI. The image recognitions, we can use it to identifications of the species. Our school have at least 3 turtles. Okay, 3 turtles. Also, the boys will identify the species with the Google Lenses. We can share some machine learning or things like that. Okay, and then we have joined other STEAM competitions like Robot Master. Okay, nearly half of the Form 2 students have joined the Robot Master. Using PhD simulation is easy. There's QR code you can scan. It's a free website. Everyone can use it. But an advice to all science teachers: some teachers just use the simulation. The boys play for 15 minutes, play for half an hour, and then okay, at the end of the lessons. However, you need to set proper worksheet to test their understanding. Otherwise, your student will just think that, okay, we have half an hour to play the iPad, and then we can go to recess. This is not the case. They should have a proper design worksheet to reflect what they have learned with the PhD simulation. So this one is density simulations. We have the traditional density column experiment, but we also use this simulation to test on various circumstances. For Form 2, Chapter 8, the circuit operation. For example, overloading is very dangerous for physics lab. We do not allow students to perform short circuit or overloading in the traditional lab. However, with the simulation, we can set some example on short circuit and overloading, so they know how dangerous it is. Okay, so we set proper worksheet for them to work on. For my ML assignment, I have given that the hypothesis whether using e-learnings or various innovative tools can increase student learning motivations. I think the data is very positive. And finally, we are now using AI platform on Form 1, energy consumptions about the predictions. Okay, predict, observe, explain is the standard scaffolding for us to teach science. sometimes we want the student to make some prediction with the AI tools. And then we try to monitor marine ecosystem with some AI tools and see that what will be the human's impact on the environment or on the ecosystem. For this QR code, there's a very interesting website, so-called Machine Learning for Kids in UK. Science teachers or math teachers, design technology teachers will find it more easy to adapt AI in your traditional classroom. However, just think about if you were a Chinese teacher, if you were a language teacher, especially this conference, we have a lot of English teachers from all over the world to come to AsiaTEFL. So with my 20 minutes sharing, I think that the language teachers or the history teachers can adapt AI very easily. One more ideas. Our school have followed some EDB scheme support by our HKSAR local government. We have used the AI to analyze some science journals for the more capable students to read the broadcast researches. And we also use the AI to assess the science model proposed by our Form 1 boys. I have given them one simple question in Form 1 science. How do you test seawater and different from distilled water? We are the adults. We know that the salt concentration will be different. One is salty, or the distilled water should not have any minerals after performing distillation. And then the boys will design various experiments. For example, they say that they want to test the pH. One student, their parents, they say that test the conductivity with simple circuit. We will use the AI to assess the student model. Okay, and let's see the comment generated by the AI, whether your model is workable. Okay, so there are many possibilities of using AI. I think we have a new conference, so-called AI in education. You have heard from me 10 minutes about the using different kinds of innovative activities. And for my point of view as the head of this group, my colleagues have told me my boys have better summative assessment result in the test and in the examination. They like your teachers. They have fun in science lessons. They have developed intrinsic learning motivation. Otherwise, they just tackling the public exam. They only have the higher extrinsic learning motivations. Okay, but however, this is not my MF research. This is not my MF thesis. It's just a very simple sharing today in this online platform. So I'm not sure whether it's workable in all Chinese school, in all school in Asia, Singapore, Malaysia, Japan, or somewhere else. I'm not sure. But I think that these 20 minutes can give us some insights on the various things that we are doing. Except the e-learnings and some innovative tools as part of China. Okay, Hong Kong SAR, all the teachers must bear the national security education duties. And also, we want to develop a better value education in the junior science school-based curriculum. Sorry, guys, I don't have enough time. I only have less than 20 minutes to present. So, but I think that for Hong Kong teachers, you can always have discussion with them. They always have some good insight on performing a better security education, especially it's very important in China. Future development, we hope to have more cooperation, especially you know that I now studying in AsiaTEFL. My teacher taught me well in AsiaTEFL. So I want to have more cooperations with the university. As STEAM education is important, we want to have more self-directed assessment in this aspect, develop more online learning packagings. For my school, we always encourage our boys to join local or international science competitions. And we look for more competitions opportunities to enrich our boys' learning science content. The students are motivated to learn with the e-learnings and also the innovative technologies we have developed for the school-based technologies. And the effect is long-lasting. Although then it is only the panel heads of Form 1 and Form 2s only. However, I also need to teach up to Form 6, the DSC curriculum. So our students need to tackle the examination of Hong Kong DSC, and then they get into the university. So they have strong interest in studying science, physics, chemistry, or biology. Then the e-learning resources actually broaden their horizons and then encourage our students to select the relevant DSC subjects. Okay, not all Hong Kong SL students only study BBA, accountancy, or they only like economics, geography or computer science in the university, although AI is very useful. Okay, 5G networks is very useful in Shenzhen as well. However, we still want more students to work in the biotechnology industry to contribute to science. Most of the conference attendants, I think you are teachers or you are professors, lecturers working at the university, or you are teaching the education student who are the future teachers. So I think that this is the terms I learned from Dr. Maxwell Ho of AsiaTEFL, a very famous scholar in our university. He taught me teacher autonomy. It's a lifelong learning process. Okay, I completed my PhD a long time ago, and I'm now studying my Master of Education in AsiaTEFL. It's never too late to learn something new. So as a teachers, we learn something new for our students. Otherwise, the student don't know how to use AI, okay? Or the student cannot master the 21st century's skills for them to survive in the futures, okay? I like these pictures with my colleagues, the head of biology, and also the 4 students who go to Hong Kong U for scientific competitions. And also the left-hand side is just a little cut from one of my students. I have been teaching him for 2 years only, Form 1 to Form 2. Okay, he liked my lessons a lot. Actually, he is someone who gave up study a long time ago. But with science, now he comes to school very often. He is a very good student. He's going to Form 3 next year. All right. So thank you. That's it for my presentation. So if you have any opinions, so feel free to contact me.